This video is an algebra review of factoring quadratic where the a value is not 1. And what does that mean exactly? Well, consider the standard form of a quadratic. That would be ax squared plus bx plus c. And we can see that the a is the number multiplying x squared, b is the number multiplying x, and c is the constant. So we can look at how this is different. So we'll start by saying consider an example where a equals 1. These are very easy to factor because we write our two sets of parentheses and we say, well, what do we have to multiply together to get x squared? Well, that's easy. It's just x times x. And then we say, what two numbers multiply to equal 6 but add up to 5? Well, that's 2 and 3. And we're done. That's all that's to it. But when a is not equal to 1, the possibilities, there's many more that we have to consider. So if we consider 6x squared minus 11x minus 10, we say, well, we can't just make our parentheses and say x times x, because it could be 2x times 3x, or it could be 1x times 6x. And now there are many more combinations we have to consider. And as this a value has more factors, the possibilities increase. The number of combinations increases, and there's too many different ways it can go. So we have an algorithm we use. We are going to reverse the distributive property so we can do this without guessing. So here's the problem that we wrote on the previous slide, 6x squared minus 11x minus 10. We start by acknowledging our a, b, and c values. And the way this starts is we look at a times c, which is 6 times negative 10, which is equal to negative 60. And we ask the question, what factors of negative 60 add up to equal negative 11? And notice that negative 11 is the b value. So we multiply AC, and then we want factors of AC that add up to b. And this is because we're reversing the distributive property. So the numbers that we're going to use are negative 15 and 4. And you might say, well, how did you get those numbers? So I'll demonstrate this once, but moving forward with other examples, I will just give you these numbers. If you can't find these numbers in your head, you can create a factor list of negative 60. And for other problems, whatever your a times c value is, that's what you would put here. And we start with negative 1 times 60. That gives us negative 60. But now we want the sum of the factors. Negative 1 plus 60 equals 59. And we say, well, that's not negative 11. We want negative 11. That's the number that we want. So we go on. Negative 2 times 30 gives us negative 60. If we add those together, we get 28. Still not negative 11, so we keep going. Negative 3 times 20 is 60. If we add those, we get 17. Getting closer to 11. Negative 4 times 15 is equal to 60. If we add those, we get 11. And we say, well, we want negative 11. So we have the right number, but the wrong sign. So we're simply going to switch it. We're going to say, well, negative 15 plus 4 gives us negative 11. Those are the two numbers we're going to use, negative 15 and 4. So now we want to use negative 15 and 4 to split the b term. So that 6x squared minus 11x minus 10, we're splitting this up. This negative 11x is now negative 15x plus 4x, because negative 15x plus 4x is 11x. And then we just bring down our minus 10, we bring down our 6x squared, and we have 4 terms now. We're going to divide those 4 terms into 2 groups, so we're working with 2 smaller problems. And now we say these left 2 terms, what is the GCF of those left 2 terms? Well, they're both divisible by 3, and they're both divisible by x, so 3x is the GCF. And if we divide each term by 3x, we get the quotient. So now the 6x squared minus 15x is going to give us 2x minus 5. And you can see the work I did down here. 6x squared divided by 3x gave me the 2x, and negative 15x divided by 3x gave me the minus 5. That is the quotient. Now we go to the right 2, and we say, well, what's the GCF of 4x and negative 10? And you should say 2, but we want to say positive 2. We want to make sure we include the sign because that's part of our answer. And then the parenthesis, divide each of these by 2, you get 2x minus 5. Now you see that we have a match of parentheses here, and that's part of the problem. We need to get a match. That matches one of our factors, and the GCFs form the other factor. So 3x plus 2 are the 2 GCFs we bring together, and 2x minus 5 is the repeated factor, and this is your answer. Now, if you wanted to check your answer, you would multiply these together, and you'd say, well, 3x times 2x is 6x squared, 3x times minus 5 is minus 15x, and then you would take the 2 times 2x, which is plus 4x, and you would take the 2 times the minus 5, which is minus 10, and then you would say, well, combine the like terms in the middle, right? So this is just a check that the factors were correct, but it also shows you the connection. Notice that we did the distributive property, and we got negative 15x plus 4. And you say, well, why did we split that middle term up before? And we see, well, that was reversing the distributive property, and that's what we were using here. So right here is your final answer for the factors. Let's go to the next problem. You can pause the video here, try this by yourself using your notes, unpause it, and I'll work through the problem. So now we're going to start by saying, let's take our A and our C values and multiply them together. A times C is equal to 24. And we want factors of 24 that add up to B, which is 10. And hopefully you say 6 and 4. 6 times 4 is 24. 6 plus 4 is 10. Those are the numbers we're going to use to split up the middle term. So now that you have your 4 terms, divide it into 2 groups of 2, and you say, what is the GCF on the left-hand side? Well, both 8 and 6 are divisible by 2, and x squared and x are both divisible by x. And then you say, well, let's divide everything by 2x, and that should give you a 4x plus 3. And now you say, what's the GCF of 4x and 3? And you say, well, they have nothing in common, so it's 1, but it's a plus 1, so make sure you put your plus there, and then your 4x plus 3. And now you take your GCF factors, and you bring them together inside the parentheses. That's one of your factors. And then the repeated factor, you count that once, and that is your final answer. So now we're going to look at an equation. The ones we looked at before did not have an equal sign, so those were just expressions. Now we have an equal sign. We're solving an equation. And anytime you see an x squared and an equal sign, your step 1 is to get 0 on one side. So we're going to add 3x squared to both sides. We see that negative 3x and positive 3x squared cancel, 7x squared plus 3x squared is 10x squared. We bring down our minus 13x equals 3. Now we want to subtract 3 from both sides. The 3's cancel. That's going to give us a 0. And since 3 is not a like term with anything, we're going to write 10x squared minus 13x minus 3 equals 0. And we have our quadratic trinomial that we're going to factor and set each factor equal to 0. So now we can say that our a value is 10, our b value is negative 13, our c value is negative 3, and we can say that a times c is 10 times negative 3, which is negative 30. So the question is, what are factors of negative 30 that add up to equal negative 13? Hopefully you say 2 and negative 15, and we can now split this up into 4 terms. Negative 13x is the same as 2x minus 15x, and we can bring down our other terms. And now that we have our 4 terms, we divide it into 2 groups of 2, and we say, what is the GCF of the left-hand side? Well, that is 2x. Divide each of these terms by 2x, and you have 5x plus 1. And on the right-hand side, we say, what can we divide negative 15x and negative 3 by? And we say, well, they both are divisible by negative 3. And when we divide both of those by negative 3, we get 5x plus 1. We bring our equals 0 with us. And now the 2 GCF factors come together. 2x minus 3 is one of our factors. The 5x plus 1 is the repeated factor, and we write that once. And it's equal to 0. So now we say we have 2 sets of parentheses that when they multiply equal 0. The only way you can multiply and equal 0 is if one of your parentheses is 0. So we say 2x minus 3 equals 0, or 5x plus 1 equals 0. And if you solve each of these for x, you get x equals 3/2, or you get x equals negative 1/5. And those are your 2 answers. So here's the next problem. Pause the video here. Try to solve it yourself. Remember, get 0 on one side of the equation, then factor, then set each factor to 0 and solve. After you're done, hit play, and then check your work with mine. Okay, so here's the problem. We want to get 0 on one side. I'm going to start by subtracting x squared from both sides. And now we're going to subtract 5 from both sides. Because 5 is not a like term with anything, we now have 3 terms, and the equation is equal to 0. Our a value is 3, our b value is negative 14, and our c value is negative 5. So now you have to ask yourselves, a times c equals negative 15. What 2 numbers multiply to negative 15 but add to negative 14? And your 2 numbers should be 1 and negative 15. They multiply and equal negative 15. They add and equal negative 14. And we're going to use that to split the middle term. So here is my 4-term polynomial equal to 0. I'm going to divide it into 2 groups of 2. What is the GCF of 3x squared minus 15x? 3x. When we divide both terms by 3x, you should have x minus 5. And then you say, what is the GCF on the right-hand side between 1x and negative 5? Well, plus 1 is your GCF. And then if you divide everything by 1, you get x minus 5. And we bring the GCFs together to form one of the factors. The repeated parentheses, we use it once as the other factor. and it is equal to 0. Now we say two sets of parentheses that multiply to equal 0 means that one or the other must be 0. And if we solve the top equation, 3x plus 1 equals 0, you should get x equals negative 1/3. And if you solve the bottom one, x minus 5 equals 0, you should get x equals 5. And these are your two answers. So that is the end of this lecture. Go back, watch it again, take notes, and do your practice problems. Come to class with questions.